This program allows students to take some data and linearize it to get the equation of their experimental data. So here's a graph of pressure versus volume, and students can see that it looks like it's an inverse graph. So they will take their x data and they will apply an inverse transformation to all of their x values, look at the graph again, and see that it's linear. Then they can get their curve fit along with their equation of the graph. Okay, it doesn't just work on inverse, it works on lots of different types of graphs. So here is speed versus energy. And students can see that this looks like it's a squared graph. So they can come back here, transform it to square each of the x values, look at their data again, see it's linear, and get the equation of energy versus speed squared. Okay, we can then go back and look at a graph that is involving angles. This is for the acceleration for an object on a frictionless inclined plane. Students can see that it looks like it might be square root or sinusoidal. In fact, it should be a sine relationship. So they would go in here. Since they collected their angles in degrees, the first transformation they want to make is change them to radians. Then take the sine of all of those values, go back to their graph, and get a fit. Finally, I wanted to show one that's a little more complicated. This time, the fit involves an inverse squared relationship, distance versus force, for maybe two charged objects. Students can see it looks inverse-like, but that alone will not straighten out the graph. So students could square their x values and then take the inverse of all their x values, graph it, and then fit it. Again, they could then look and see what their relationship is and get the equation for their graph.